Welcome to my session on design patterns. This is a 1.5-day workshop. The goal is to learn some design patterns in a practical way with PHP. So we'll cover about 10, 12 design patterns. We will not practice all of them, but the goal is to give you a better understanding of these design patterns and why you should implement them. So my name is Hugo. I'm from Paris. I live in Paris for 10 years now. I used to work for Sensio Labs, the creator of the Symfony framework, for about 9 years. And at the beginning of this year, I joined this startup called theyuse.com. This is a platform where we sell hotel rooms, but for the day. So the goal is to increase the revenues of the hotels. So for this workshop, we have a first chapter of this workshop, which is dedicated to object-oriented design. I will just go over some important concepts about object-oriented design. And then we will go on the design patterns. Because as you will see, these object-oriented design concepts are very important, and they are also leveraged by design patterns. All right. All right. So one of the first concepts that is very important to know about is dependency injection when you deep dive into object-oriented design and design patterns. How many of you already heard about dependency injection? Yeah, okay, most of you. Okay, cool. So yeah, so basically when you, dependency injection is basically when you give your objects their dependencies using methods like construct method or setter methods. That's not dependency injection. As you know, in this case, we are instantiating the dependencies of this class, chase game loader, directly into the construct method. That's not dependency injection because the chase game loader class is responsible for creating its own dependencies. And the problem with that is that we are very tightly coupled to these particular dependencies, and we can't swap them and change them for different implementations. All right, so tight coupling as the main problems. We are depending on concrete classes as we are using the new keyword. That's the main problem. And so this code is not super testable and not very flexible because we can't change the dependencies as they are hard-coded. So dependency injection is just about passing those dependencies explicitly into the construct method. In this case, I'm still using the concrete classes, so we are still tightly coupled to these concrete objects, but at least we can create subclasses of these classes and pass different implementations. That's dependency injection. So the code now is unit testable. It's easy to unit test the class. You can mock the dependencies. For instance, you can mock the Redis cache object if you don't want to use Redis in your test suite. You can change the dependencies. Even though they are concrete classes, you can subclass the classes. However, we are not relying on abstraction in this case. I'm still using concrete classes. It should be better to depend on interfaces or abstract classes to raise a level of abstractions. But that's another story. So dependency injection can be leveraged by dependency injection containers. If you are familiar with frameworks like Symfony, for instance, you know that there is a central object which is responsible for creating your services or your dependencies or your main objects. That's the role of the container. And basically a container is like a factory. That's a sort of implementation of a factory design pattern. Sort of, it's not really a factory. So if you use, if I go back to this example, as you can see, if I want to use my chess game loader class, it becomes quite difficult to set up because we have 3 dependencies, and those 3 dependencies may also have other dependencies. So as we have a complexity for producing the object, we can leverage a dependency injection container, for instance, to encapsulate this part of the construction. And so as I said, the container is, so this is an example with Symfony where we describe the dependencies, and at some point we tell that this class chess game loader is going to receive these 3 objects in its construct method. So I'm using, in this case, a YAML file to describe how I will create this chess game loader object. The point is, it's not about telling about, I'm not about advocating for a container, but as we are talking about design pattern, the container, as I said, is a sort of factory because it centralizes the creation of an object, so that the new keyword, new this class, is centralized in one single place so that you can easily change it at some point without impacting the rest of your application code. All right. So if you use a container is a sort of factory. All right, makes sense for now? For everyone? All right. Second important part of object-oriented design is composing objects, or object composition. As you will see, the design patterns are, they really leverage this concept. We are not really using inheritance in design patterns. Instead, we will favor object composition. So the goal of object composition is just to embed objects into objects so that you can create more complex types or more complex objects, and using delegations. So still this class, it's a composition as we are passing different objects in the construct method, and then we are delegating some task to the injected objects. That's basically object composition. But you will see more interesting use cases with design patterns. We have patterns like the Decorator pattern, for instance, which is one of the most famous, which leverages this concept of object composition instead of inheritance. What do we have? Yeah, so I'm passing, just remembering what I wanted to explain here. I'm passing some repository. Yeah, so this method load tries to fetch from some cache system, deserialize some string to recreate a chase game object. Otherwise, we fetch it from some storage engine. And so, yeah, okay. So in this case, we have another implementation of the repository. As you can see, we have a Redis chess game repository. Same, this one. So it has a cache object injected, and then it serializes the object and then caches it somewhere. No, it loads it from the. Okay, it loads it from Redis, but let me check. Yeah, okay. I wanted to show you how we can combine the two strategies: loading from the memory or loading from some Redis cache or something, or Redis repository. So as you can see, in this case, the chase game loader object has two dependencies, two repositories. The first one tries to load the chase game object from some Redis, cache. So if we have it in Redis, then we return this object from Redis. Otherwise, we will fetch it from some database or in-memory storage. If you look at closer, they both share the same interface. We have both by ID method. They are both repositories. So we can leverage the object composition here to combine those two objects into one. And one way to do it is to use, in this case, it's a composite design pattern, as you will see later when we cover this pattern. But that's object composition. I will create a new class, chain chase game repository, which implements the interface, chase game repository. So I have this by ID method, and then this object will combine as many repositories as you want. And then the by ID method will simply iterate over each repository, and the first one that manages to retrieve the object by the ID will return the object. And we are still fulfilling the interface or the contract. As you can see, we must return a chase game or null. This is what we do here. We have a game, otherwise we have null in the end if we can't manage to find anything. So in the end, I can simplify my chase game loader class. Instead of injecting two concrete objects, two concrete repository objects like Redis and in-memory or database, whatever. Instead, I will type int against chase game repository interface. And this way, I can inject either an in-memory chase game repository or a Redis chase game repository, or even better, my chain chase game repository. And in the end, we just have one method call here on the repository. So with this single interface, my chase game repository interface, now I have three different implementation, two concrete single implementations, and one which is a chain or it's a composite object of repositories. And that's an example of making object composition. Right. Now, the solid principles. Who heard about solid principles? Okay, quite a few. First principle, which is single responsibility. So basically, one class should have only one responsibility or one reason to change, as per Robert Martin says. So if you can identify that in your class, at some point you have at least two reasons to make this class change at some point, that means there's a lot of probability that this class has at least two different responsibilities and that you should extract one of the responsibility outside in a separate class. So we have this class again, so new class chase game runner with a new method, start new game, which takes on chase game context. And then as you can see, this class does some stuff. Can you spot the responsibilities in this class? As you can see, the class is quite short. There's not much, but still, we have different responsibilities. I'm sorry?
Loading and starting.
Yes, loading and saving. So there is a first responsibility here, which is producing a game object, creating a game object. And a second one, which is then saving the object. All right, so there is two different nature of responsibilities, object construction and persistence layer. So we should extract this piece of the responsibility into a dedicated class so that the chase game runner will simply delegate this responsibility to someone else or to some other objects. So for instance, the chase game construction can be extracted out to a factory, for instance. That's one use case. So now as you can see, if I switch back, oops, there it is. So in this class, we inject in the construct method some user repository. But now, as we are going to extract this part to a factory, then we will inject the repository into the factory, and we will simply inject the factory in ChessGame runner. So, what is this? So, ChessGame factory then receives some user repository, user account repository, and then this factory is responsible for producing a ChessGame object. And that's an example of a factory method design pattern implementation here. We are producing one single type of objects, and we encapsulate the creation of this object. As you can see, this factory, it allows you to create a ChessGame object with two opponents, two players, two user accounts. But maybe you could imagine also having another factory which also creates a chess game, but one concrete player to the artificial intelligence system. So you could just simply have two different implementation of the factory. So maybe you will have an interface. You could have an interface. And so this way, in your chess game runner object, in the main object, you will either inject the factory which allows you to create a chess game for two players, or the other factory which creates a chess game for one player against the machine. All right? But it doesn't change the way your chess game runner main object runs. All right. So we simply delegate the creation of the game to the factory, and then we save it and return it. All right, second solid principle is open-close, which is probably one of the most difficult to understand. You should be able to extend an object behavior or a class behavior without modifying it. What do you know or what would you say about this principle? What does it mean? Yeah. Yeah. So basically, you should find some ways to design your code in a way that at some point you should be able to replace some part and change it with another part, for instance, which have the same contract or the same interface. You could use the extend keyword. You could use inheritance, but inheritance is not the best way to fulfill this principle, because as you can see, the principle says that you should not modify the class. But if you use inheritance, if you inherit a base class, using inheritance, that means you are in some way modifying the base class. You are changing maybe some properties, or you are maybe overriding some methods. So there are some different ways to make a class extensible. Let's say, for instance, that we have this code in my chess game factory. Remember the chess game factory? To produce the unique identifier of my chess game object, I'm using UIDs. And so we have this class, this package, which generates a UID. Can you spot the problem with this implementation here? Or can you spot the limitation of using this class and this method? Yes, that's true. We can't use a custom class or a custom object to generate a custom UID. So in this case, every time I will call this create method, I will produce a new random unique identifier for my chess game. The thing is, if I'm running tests, for instance, in the test environment, I want to know in advance which UID I'm going to produce so that I can have a reliable test suite. So that means this small part of the algorithm should be swappable. You should be able to to encapsulate the creation of this UID. So that's a responsibility, in fact, of my factory. So I need to delegate this to a different object. So I can have an interface like GameID which returns some UID object. And then I can choose to have different implementation. So a random GameID generator, which generates a random UID, or I can have a fixed GameID generator, which always returns the same UID I've pre-configured in my system. Right? And again, my factory will receive this new dependency. In this case, this is a strategy design pattern implementation, as you will see. We are basically relying on an interface, and at runtime we change this implementation. So now I can delegate the generation of my UID to my delegates, or my identity generator delegates. So I can easily configure the chess game factory for any environment, production or test environment, to either return a random unique UID or a fixed one, especially for my unit test or my functional test, whatever. So that's the open-close principle. You make your code extensible. So as you can see, that means I'm able to basically extend the behavior of this class, chess game factory, but without modifying it. The pieces that may change are encapsulated into separate classes or separate interfaces. So I don't need to change this class. I don't need to modify a single line of code of this class if I want to change the behavior of generating a UID. Third principle, Liskov substitution principle, which means derived classes must be substitutable by their base classes. That's mainly when you use inheritance. If you inherit a class, a base class, to extend it, and if at some point you decide to overwrite the behavior of a method, you want to override a method from the base class, these concepts say that you must fulfill the exact same contract when you use inheritance. This means that you always must fulfill the exact same contract when you implement an interface or when you extend a class. In this case, I have an interface. As you can see, my interface says that the byId method takes a UID object, and it must return a chess game object. And if there is no chess game object, the documentation states that we should or we must throw a chess game not found exception. So now that means if I want to fulfill this, this principle, that means my concrete implementation of this interface must all have the exact same behavior. They must have the exact same contract. So for instance, as you will see, so this class or the repository is injected in the construct method, so we are using the interface in the construct method, and which means that we know we can have a game object, or we can get a chess game not found. So the client code, in this case, chess game runner is a client code. The client code knows that it's either a game object or a chess game not found, but it can't be something else. That's per the contract. So all my concrete implementation must fulfill the exact same contract. So if I create a first implementation, like in-memory chess game repository, then I will either return a game object, a chess game object, or I will throw a chess game not found exception. I will not raise something else as exception, because otherwise, if I inject this object into my main client code, it will break the client code because the client code expects a chess game not found exception. Same if I have another implementation, like Doctrine chess game repository. If you are using an ORM like Doctrine, then again, we will have a game object, otherwise we will get a chess game not found exception. So that's the Liskov substitution principle. You should or you must always fulfill the same contract. And one way also to do it is to use the return type-ins. As now in PHP we support return type-ins. Don't forget to use them so that if you don't return the correct type, you will get a fatal error by PHP. All right. So now in my chess game runner object, I can either inject my in-memory chess game repository or my doctrine chess game repository. They both have the exact same contract. They behave the exact same way. So for my client code, it's the same object, or it's the same dependency. ISP, interface segregation principle, which basically means make fine-grained interfaces. It's mainly the single responsibility principle, but applied to interfaces. You should make very fine-grained interfaces, or in other words, you should not create interfaces with too many methods, because the client code, if the client code only needs to use 2 or 3 methods over the 10, for instance, that means you will have to implement 7 empty methods in your client code. So you don't want your object to implement methods that they don't need. So that's the example I'm using. As you can see, all my interfaces are quite small in this case. They just have 1 method, but an interface can have 4, 5, 6 methods. That's okay. But if you have an interface with 20 methods, then you should wonder, are these 20 methods really required for this interface? My interface probably is way too large. If you are familiar with the Symfony framework, for instance, we have examples of this interface segregation principle implementation. Maybe you have already used the Symfony router as a dependency. You have a router interface in Symfony. In fact, router interface is a complex interface, because in Symfony the router is an object which performs 2 different tasks. A router can match a URL pattern, and the router can also generate URLs. And if you need to use the router in your Symfony classes, or in your classes, or when you're using Symfony, you can either choose to type in your dependency with one of these interfaces. And so the best is always to choose the most lightweight interface. So in your code, if you want to inject the router because you need to generate URLs, you need an object that generates URLs, then it's better to just type in against URL generator interface, so that you just have an object which has 1 mission, generating URLs. If you need to have an object which matches URL patterns, then you will type in against this interface. Or if you need both, if at some point you need to use both methods, then in this case you will type in against router interface, which is, as you can see, an extension of both URL matcher and URL generator interfaces. But always choose the most fine-grained interface. And the last one of the 5 solids principle is dependency inversion principle, not to confuse with dependency injection. They're a bit different. Dependency inversion means that you should depend on abstraction instead of concretion. In other words, you should depend on abstract types, like abstract classes, or even better, interfaces, rather than relying on concrete classes. So whenever you have an opportunity to depend on an interface, then you should choose the interface as a type int. So this way you allow your code to support different implementations. That's mostly useful when you have a testing environment, because in test environment you may want to inject a different implementation, especially for mocking or stubbing IOs or database connection and stuff like that. All right, so favor interfaces rather than concrete classes. Right, makes sense? All right, so we saw object composition, we saw the solid principles. Now we are going on to object calisthenics, which is, it's not something especially related to object-oriented, but you can apply them to object-oriented programming. Object calisthenics are a set of exercises. There are 9 exercises, if I remember. They were invented by Jeff Bay in his book. And so basically, it's a series of exercises that you repeat every day on your daily basis to improve yourself. So when it's applied to the body, that means you are training your body to have more muscles, for instance. But for the code, it's a series of 9 exercises that you apply to your object-oriented code to make it better. And these are the 9 exercises or the 9 concepts. One level of indentation per method, that's one of the concepts. Or, of course, as you can see, the concepts like one level of indentation is quite rude or it's very extremist. Of course, you will not want to do that 100% on your code, but the goal is to try to implement these exercises or to apply these exercises to your code to improve the shape of your code. So don't use the else keyword, wrap primitive types and strings, 2 instance operators per line, don't abbreviate, make short and focus less. So this is basically the single responsibility principle. Keep number of instances properties low. So that means in a class, you will try to have just a minimum amount of properties or attributes, especially when you have to deal with services, like objects like services, for instance. I'm not talking about entities, if you are familiar with doctrine and entities. Of course, an entity can have 30 or 40 properties because they map 30 or 40 fields in your database. So some classes are not concerned by this concept. Treat list as custom collection object. So basically, instead of using arrays, you will create collection objects. And my favorite, avoid public accessors, like avoid public getters and setter methods. So that's an example, the first one, wrap primitive types and strings. I will not go over the ninth, but the most important one. Again, I have my chess game object. And as you can see, the chess game has we have a chessboard dependency. And at some point, I want to make a move on the chessboard. And so this method, make move, takes a pawn, and we are giving the coordinates of the pawn, and then we want to move to the next one. So first of all, we have to ensure that it's a valid move for this pawn, and then if it's a valid move, so this method will basically throw an exception if it's not a valid move. Otherwise, then we can perform the move. So the principle called wrap primitive types into objects, that means whenever you have a set of properties or attributes or variables that are very linked together and that they form a concept as itself, then you should encapsulate them into a class or into an object. Can you spot an example here? Yeah, the coordinates. So as you can see, we are using, in this case, 2 primitive properties or attributes, 2 integers, origin row and origin column. And in fact, the properties, they form some coordinates or they represent a cell on the board. So maybe I could encapsulate them into a cell or square object, right? So then I have a new class called square, and the good thing is that I can also validate the coordinate, because I know that on a chess game we have just 8 rows and 8 columns, so the coordinates must be in this range. And it's an immutable object, basically. It's a value object in this case. Once we have set the attribute or the properties, you can't change them. You just have getters that are exposed, but you don't have any setter method. So now I can refactor my make move method. As you can see, we just have now 3 3 arguments instead of 5 previously, so it's better. But we can maybe still go further. Could you imagine another refactoring? Can we still combine objects? Yeah. Yeah. So we may. Well, it may make sense if you want to in object-oriented design, you want to now describe in a chess game what's a move, because in this case we want to describe what is a move. Then I maybe want to join these 3 objects together in a move class. All right. So in this case, I have a move object. So a move is a pawn from one square to another square. And so now this way my method make move just takes 1 object, and it simplifies this a lot, as you just have one argument instead of 3, right? So every time you have this, you have the opportunity to wrap object or combine object, especially when you have to deal with primitive types like strings, like integers. Then you should wrap them in objects. Another good example of it is currencies, how you deal with currencies or money. If you have to display money, or if you have to deal with monies, for instance, a money is a number, like an amount, a number, and a currency code. And so instead of having 2 attributes, 2 single primitive attributes, like amount and currency code, then it's better to wrap them into a money class, where you will store both attributes. And then your money class will probably expose methods like adding 2 money together, or subtracting monies, or dividing monies, and so on. And so you can find some money libraries with Composer. You have some famous ones. And so now in my code, every time I have to deal with monetary values, then I always use a money class, so that I'm sure that I have a consistent money representation in my system. Right. 1 level of indentation per method. So this one is a bit extreme, but it's interesting to know the techniques to simplify code. So as you can see, in chess game, I have this make move method. So if the game is not finished, then I want to check if it's a valid move. And if it's a valid move, then I want to perform the move. As you can see, this method has 2 levels of indentations, while we should have only 1. So what would you do to reduce the number of indentation levels? You could, but that's not the best way. But yeah, so basically you should reverse some conditions. Like the first one, instead of testing that the game is not finished, then you can, in this state, you will choose that if the game is finished, then you will perform a return or an exception. All right, so you can now write the code like this. So if the game is finished, then I will throw some exception. And if the game is not finished, then I will check that it's a valid move. If it's not a valid move, then again, we have an exception, and otherwise we can perform the move. And so this way, when writing the code like this, you can clearly identify which paths the code can take at runtime. So you can take this path, or this path, or this path. So you have 3 different paths. So at least you need 3 different unit tests if you want to 100% cover this method with unit test. And so it keeps your code highly readable. So whenever you have the opportunity to fulfill this principle, I encourage you to do it. All right. Something I like to do also is to encapsulate these into methods, very short methods that are very expressive. As you can see, ensure game not finished, ensure valid move, and the methods are returning void or an exception. And so this way, the main method, the main method simply, this one, make move, it simply calls the series of steps. So it makes the code more readable. Avoiding the else keyword, this is one of the most important. Whenever you have the opportunity to avoid using an else keyword, please do it. So it's the same. You simply reverse the condition, and then you return or you throw an exception. Like for instance, this one. If the game is finished, then you can either return nothing if the method is configured to return void, or you can throw an exception. But avoid having an else statement which is useless for the code. Two instance operators per line. This one again is also a bit extreme, as you will see. That means you should not have more than 2 rows per line, per statement. In this case, as you can see, I have 1, 2, and 3 instance operators that are called consecutively. That means my chase game object or my chase game class has too many knowledge. My chase game has a knowledge of the chessboard, which is a close neighbor or close delegate. But the chess game also knows about the move. The chess game knows about the target square, because the getSquare method returns some square object. So we have an implicit dependency here with a square, and then on the square, then we add the pawn. So it should be move and then a row get pawn or something like that. I made a wrong refactoring. But yeah, as you can see, we have 3 different, we have 3 instance operators on this line, and we should only have 2 to reduce the knowledge the chess game object has with the dependencies. So one way to do it is to give more methods to the chessboard object. I will simply expose another method to chessboard, and the chessboard itself will only know about the square, because the chessboard knows about the 64 squares of the game table or the game board. My chess game object doesn't have to know anything about the squares. It's an internal detail of the chessboard. So as you can see, in this case, we went down from 3 rows for the statement to only 2, which reduces the knowledge the chess game has with the other objects or with the chessboard. Avoid public accesses methods. That's one of my favorites, especially if you design entities. Because if you're familiar with Doctrine and Symfony, for instance, you may be tempted to create an entity and have private properties, and each property is exposed with a getter and a setter method. If you do that, that means at some point you will have some what we call anemic model. So you will be tempted to extract the business logic outside of your entity, and you will just leave your entity empty with just a container of properties. That's an example. Here we have some invoice entity object. And as you can see, in this case, my invoice object has many setter methods. And of course, it has the getter methods. What's the problem with this implementation? What's the problem of having too many setters? Mm-hmm. So you are not guaranteed that each property is set, which means your object may be in an inconsistent state at some point. All right. And first of all, the construct method, as you can see, my construct method doesn't take any arguments, which means I can produce an invoice object with no invoice number with no due date, with no default status. That's something that should not happen in your domain. So this is why instead you should use the construct method to inject all the arguments that are really required to make your object in a valid state. And then you will just expose the method which performs business logic and turns the state of your object into another state in an atomic way. So in this case, my entity will receive dependencies. So I will force the construct method to receive the minimum required attributes to make this invoice in a valid state. Like at least I must have an invoice ID. So again, as you can see, I converted my invoice ID to an object. That's the primitive type concept. It's just a value object. But this class, invoice ID, will also ensure that the string has this format, because maybe that's important for my domain to have this format for all my invoice numbers. So having a class like invoice ID will ensure that we have this formatting. As you can see, I'm also wrapping the monetary values into a money class. So it doesn't make sense to separate the amount and the currency code, so they are both encapsulated. And the due date is a datetime object. So whenever you have the opportunity to also use objects, then use the objects. So now if I want to issue an invoice, I will use the construct method, and my object will be in a valid state. So now we have a valid new invoice in the system. It has an invoice ID, it has a due date, and it has an amount. And as you can see, when you use money classes, the amounts are expressed in cents or in the lowest currency value or lowest units of the currency. So in this case, it's an invoice of 99.90 euros. So now, how can I turn the state of this invoice to another state? As you can see, my invoice has other attributes like overdue amount, because maybe I will overpay this invoice. I will collect some payments because maybe the client wants to pay the invoice in several pieces. And we have a closing date. So whenever the invoice is fully paid, then we will also set this closing date to know on which date the invoice has been fully paid. So I don't want to expose setter methods for these properties because they must be set all at the same time in an atomic way. So this is why instead I'm going to expose a collect payment method which takes a payment object. So the payment object contains the information about the payment. Maybe it's a check or it's a cash or it's a credit card transaction with the amount and so on. And then I will make all the calculus in this method. And so using money class, as you can see, using the money class, I can make some useful operations like subtracting or getting the absolute value of the amount. Or I can compare two monetary objects together and so on. So it simplifies this a lot when you have to deal with amounts and monies. And so, as you can see, if at some point we manage to have the amount of money that was charged, that equals the amount, then we can close the invoice. The invoice is considered paid. Otherwise, if we overpaid this invoice, then we will also store the remaining amount that we have to maybe refund to the customer. And I will also keep a collection of all the payments. So as you can see from payment, then I have a collected payment. So I have another class which expresses that payment was collected. And my class will only expose some useful getter method to expose the state, like is closed, is paid, is overpaid, and so on. But I don't have too many setters. The only setters basically is this one, collect payments. All right. So try to avoid setters and getters. Make your entities or your object encapsulate their business logic. And I think this is the last one of object calisthenics, is treating list or arrays as collection of objects. So remember my list of payments, which used to be an array, but maybe it's better to have a collection because I may want to perform some dedicated operations on this list of payments. So I can use some array collection class, like if you use Doctrine, for instance, Doctrine has a Doctrine collection package where you can find this class. And so now, on this collection, I'm going to add a collected payment object. And at some point, I would like to get information about the collected payment. Maybe for my invoice, I would like to know how many payments have been received after the due date, just to check if the customer pays late or if he pays on time. So using the collection, as you can see, the collection class has some useful filter method, which takes a callback, and then it applies the callback on each element of the collection, so on each collected payment, and then I can decide which one I want to take or remove from the collection. So it returns a new collection which only contains the collected payment that fulfills this condition, and then I want to count the collection. So in this case, I'm using a generic collection, but you can also do something better, like creating a custom collection class if you want to expose this method. Like I want to extend the array collection and then expose a received after method where you can pass a date, and then you will simply encapsulate this business logic or this small logic into your custom collection. All right, so now my invoice class has this method, count payment received after due date, and I will simply get all my payments, then use my new method, received after, passes the date, and then count the number of items. So it makes the code more expressive in this case. That's another way. That's also a limitation because if you use Doctrine, an ORM like Doctrine, the problem with Doctrine is that Doctrine doesn't support custom collection. They only support their type of collections, like array collection. So you can't really use that if you use an ORM, or you have to reconvert the Doctrine collection into your custom collection with some getter method at some point. Right, make sense? I think that's the last sub-chapter before design patterns. Value objects. So we already talked about value objects. That's another important concept of object-oriented design. And this value object concept is also used widely in a design pattern called flyweight, as we will see this afternoon or tomorrow. So a value object is a very small and lightweight object which represents one single atomic value, like as we saw, an invoice ID, or a money, or a square, or whatever. It's a very lightweight object. And a value object is responsible for validating its own state. That means when you pass the state of the value object in the construct method, then the construct method will ensure that you are giving it a valid state or some valid values. And if it's not, you will get exception, preventing from constructing this value object. And then, once the object has been constructed, you will be sure that your object is in a valid state, and also that the object is consistent, and that it's immutable, because a value object by nature is an immutable object. So once it's created, you can't call any methods, any setter method which changes its state. So you can easily reuse it and passes it to other objects safely because they are not changeable. So value objects don't have any identity, so they don't contain unique identifiers, because a value object only encapsulates a value but not an identity, compared to an entity which has an identity. So they validate their own state. They are immutable. They are always valid by design. Two value objects are equal if the values stored in their fields are also the same. Okay, so the equality is based on the field's values, but not on identity, because there is no identity in the value objects. And the good thing is that as they are immutable, you can easily swap a value object with another value object which is equal without having any side effects. Like if you have a money, let's say a money object, if you want to represent 100 euros as a money object or as a bill, you have 100 euros as a bill and you have 100 euros as coins. In the end, it's still 100 euros, whether you use coins or whether you use bills. So you can swap them. It doesn't change anything about the value. So that's the same for value objects. So this is the example with monies. So like a currency code can be represented as a single value object. As you can see, the class is final. It takes just a currency code, and it ensures that this is a valid currency code. Let's say that my system only supports euros, USDs, and Canadian dollars. So to make sure that I will always have to deal with these currencies, then the currency object will ensure that I'm not passing some invalid currency code. And the two currency objects are equal if they have the same attributes or the same fields. If I try to support bitcoins, for instance, my system will refuse because the value object has a rule preventing from storing bitcoins. And then you can combine a currency with a money object. So that's object composition, so it's a composite value object. So then we have a money class which contains the amount expressed in the lowest, in the smallest units, like cents for euros or dollars, and the currency code. And then you will get methods like add, if you want to add two money together. So you will first ensure that you have the same currency. You can't add dollars with euros, doesn't make sense. So you will prevent this operation from being done, unless you have some currency exchange rate system. And as you can see, when you add two money together, you are not changing the actual object, but you are simply returning a new money object, which contains a new value, which is the sum of the current amount and the other amount you want to add to it. And we can safely reuse the currency object because it's a value object, it's immutable, so you can pass it along to another object. So you can share the same value object. So if we have, I want to add €1 with €5, then I will get €6. But if I try to add then €6 with 3 USDs, then it fails because we have different currencies in both objects. So again, I'm sure that of the integrity of my objects. Right? Yeah.
What's the possibility to inject mandatory, say, the value objects? Because maybe I want to use the same object to imagine a different currency, example, that would say that I use a USD, Canadian dollar, and euros, and in other cases I use Ethereum or coin. So I have to generate two different money classes, or I can use the same money class and inject a different validator to manage.
You can use the same money class. There is a package if you search on Composer called Money PHP, which is a money class which also has some strategies for currency exchange and so on. They also supports bitcoins and stuff like that. So they perform all of this in their money object, money class. So you have one single money class, and then they provide features like adding, subtracting, dividing, or splitting money. That's something interesting when you deal with money. Let's say you have 100 cents, so you have €1. No, you have 99 cents, and you want to split it in 10 equal shares. So 99 cents in 10 equal shares. So if you use a money class, the algorithm behind the money class will make sure that you will get 9 people who will get 10 cents, and then the last one will just have the remaining 9 cents, because that's the closest operation we can achieve. So these algorithms are already set in the money class. So this is what I use in my project. I have this money package that you can get on Composer, and you have all the feature set for dealing with monies. There is also a doctrine money also extension, so that you can also convert this money object for persistent storage in doctrine, like so that in your doctrine mapping, you can have an object, which you can have a property in your entity which is a money value object, and you can tell doctrine that whenever you persist this money, you will persist it in one field or 2 fields, for instance, and then when you fetch the money attributes back, or when you fetch the entity back, you recreate the money object into the entity. That's quite useful as well. All right. Any other questions? Okay, I think we have about 10 minutes, and then we have a break. All right, so just before the break, I have a few slides on introducing design patterns. So now we saw all these concepts of object-oriented design, so we have a better understanding of solid principles, value objects, object calisthenics, and so on. And we will be able to use this when implementing design patterns. So a design pattern is an abstract solution to solve a common problem in software engineering. So they were invented in, if I remember, in the 70s or 80s by the Gang of Four. There's about 23 patterns. They are not all useful for the PHP world, but it's interesting to know most of them, or I mean the most famous one, and how to recognize them, how to use them in your project. So first of all, the design patterns are categorized in 3 different categories. So the first category is the creational patterns, so the patterns that are responsible for encapsulating algorithm for creating objects or assembling objects. So we have different patterns for that. So you may know the singletons, which is now considered an anti-patterns. Then we have prototype, we have factory method, we have the builder, and abstract factory. So these 5 patterns are used for encapsulating the creation of objects. Then we have structural patterns. So this one basically allows you to architecture or structure your code in a way to make your code more extensible, more flexible. So among the most famous one, you have the adapter, you have the Composite, Decorator, facade and flyweight, for instance, or proxy. Bridge is quite complex. We will not cover this one, but at least we'll cover adapter, Composite, Decorator, and flyweight, if I remember. And the last category is the behavioral patterns. That means the patterns that are that act at runtime, basically. So they perform stuff at runtime when the code runs. While the structural patterns are mostly used at compile time. So they are structural, so architectural. So they don't do anything particular at runtime. It's just the way you will use them to make your code flexible. And this one performs stuff at runtime when they are executed. So in the most famous one, you have iterator, observer, mediator, state, strategy, template method, visitors. That's the one we'll cover. We are not going into chain of responsibility or command or interpreter. Interpreter, for instance, is a pattern that is used for creating DSLs, domain-specific languages, for instance, so to parse a domain-specific language. If you are familiar with Symfony, there's a component which implements this one, which is the expression language. Expression language is an implementation of the interpreter design pattern. All right. So what's good about design patterns? Then it's good for communication because you have one pattern and each pattern has one specific role or it's one specific solution. So when the team knows the design patterns, then they know exactly what the code does, what was the intent of implementing this pattern in the code. Using patterns make your code more testable because you also have to implement the solid principles. I mean, by nature, the design patterns forces you to implement solid principles and all the concepts we've covered. And so by extension, it makes your code more maintainable and more unit testable. So that's one of the benefits. And design patterns also encourage loose coupling. So as you will leverage abstraction and interfaces, then you will also reduce coupling at the same time. In the downsides, they are quite hard to teach because it's difficult to find some good documentation about design patterns. You have the famous book from the Gang of Four, but most of the examples are in Java and .NET, and they are applied to these worlds, not to the PHP world. And if you look some code samples on the internet, you always find some educational examples, but they are not really real-world examples. So that's also one of the problems to get into design patterns. All right. Just be aware, the design patterns are not the holy grail. So it's good to know how to use them, how to implement them, but don't try to abuse them and to always implement them in your code because you may also end up with an over-complex architecture. Sometimes it's better to do something simple. You don't always need to implement a pattern in your code. Yes. Yeah, so I think we can go because we can take the short break. Okay. Any questions? No, it's okay. So we can get to the break and then we will start playing with some patterns. Okay, good. So I usually start with creational patterns, but we'll change because creational patterns are quite complex to tackle. The first side, so we'll go into creational patterns later. I want to start with the structural pattern because they are more easily to get into. And for the first pattern we will see and practice, I want to introduce the composite pattern that we briefly showed during the first speech when I talked about the chain repository thing. That's a composite implementation. So let's see how this pattern works, what it does, and so on. So the composite pattern, as you can see in the name, composite, we have composition. So it's a pattern which leverages the object composition instead of using inheritance. The goal of this pattern is to treat collection of objects as they were just single objects. So it's mainly useful when you have nested object graphs and you want to perform some actions or some operations on one object or on a collection of objects in the same way with a uniform interface. So this is how it's designed from a UML perspective. So there is the base type, which can be an abstract class or it can be an interface. So in this case, we have some component interface, which exposes public operation, public methods. And then we have different implementations, like there is a leaf concrete class, so which implements this interface and of course has this operation methods. And then we have the composite implementation, which will be the object that will then nest component objects. So of course in this object we have the operation method because we implement the base interface. And then you can have some extra methods to embed your components into your composite. So as you can see, this add method has a component type, which means we can embed any object which implements the component interface. So we can embed any leaves or any composite objects. And so you can do it in the, with as many levels of nesting as you want. Can you see some useful use cases for these patterns in your daily job as a developer?
Trees.
Yeah, trees. That's one of the most interesting parts. If you have to, let's say, go over a file system. In the file system, you have files and you have directories, and directories contains files, or directories contain also subdirectories, and then you can represent that with a composite. That's one of the use cases. Or when you have to deal with menus, you have menus with submenus, with sub-submenus, and so on. Okay, any other valid use cases? When you have nested structure? No ideas? So navigation bar or menus, parsing XML files, for instance. You have nodes that contains nodes that contains nodes and so on. Or you can have forms. If you are familiar with Symfony, for instance, you can have a complex form system where you have forms which contain subforms, which contain subforms, and so on. Iterating over a file system and so on. So every time you have a complex nested structure, you can use this composite pattern to navigate this structure. All right. So as you can see, I have my my concrete leaf, so I can operate on the leaf, or I can have a composite which embeds both a leaf and other composite. And whenever I perform this operation, it's done on every object that implements this this method. So most of the examples I will show you are taken from the Symfony framework because the frameworks contains a lot of design pattern implementations. This is just for illustrating, but we will practice some completely different examples as plain PHP code. So no frameworks, no nothing, just plain PHP code for practicing. But the goal is to show you what's the benefit of using these patterns in complex systems like frameworks, and in this case, Symfony. So the composite pattern is used in many areas of Symfony, but one of the most interesting is the form component. So whenever you design a form, the form class is defined as a composite as itself. And the good thing is that you have one class, form, and as you can see, form is a composite of itself. So you can nest form object into form object, so you don't need to have separate classes. That's an alternative way of creating the composite. And so as you can see, we have methods like getNames or getData or isValid or submit. And so whenever you trigger the submit method with the submitted data of the form, then this submit method will be invoked on any subforms. So when you create a form system like this one, you have a product form which has a name field, a short description field, and then you have a subform which is a picture subform. And for each picture, you want to have a caption and an upload system. So then you could design your form with form objects, like you have your domain root form object, which embeds a subform field for the name field, another form object for the description, and another form for the picture upload system. And this one contains the caption field and the upload file. All right? So this is basically how, for instance, Symfony represents your web form in a PHP way, in a PHP data model. So if you want to create it, this is just a simplified version of what we have in Symfony. If you want to implement it yourself, there is a form class which can implement a base interface like form interface. So basically this interface contains the basic methods like getName, submit, and so on. So each form has a name, so except for the root form. Okay, I just masked. Okay, I masked the slides. Yeah. So as you can see, each form has a name. So you can have null for the root form, or you can have a name. And then each subform has a unique name like description, name, picture, and so on. And of course, as we have a nested structure, each form can also remember its parents and has a list of children. So when you add a new child to the form tree, then you will save the child into the children's list, and you will also remember the parents, the actual parents in the child. So this is how it looks like in the end when it's built. So in this case, I'm building the form manually, but you could imagine having some form builder or some form factory on top of it to encapsulate this complex creation, so that you don't have to repeat it. This is also what Symfony does. You have some builders object on top of the form component. But this is how I build it manually. So we have the main form, the main product form, which embeds a name and a description form, and which embeds the picture subform, which also contains caption and image. So now you want to submit the data. So your form class has a submit method, which takes the array of data. And each keys is, of course, the name of the form that you want to reach in the tree structure. So name, description, picture, and inside picture we have caption in this case. So as you can see, the implementation of the composite is quite simple. We just iterate over the children, and for each child, then we recursively call the submit method, and we passes it only the data that corresponds to this particular field. And then the submit method will do this until reaching the leaves of the form. And that's it. It's just about 5-6 lines of code to navigate this tree structure. Right? All right. So let's do some concrete example. Yeah.
Just one question. What is the main difference between a dependency injection and a composite concept?
Dependency injection is only when you inject the dependencies of your object into the construct method or any methods. So it has nothing to do with composites directly. It's just the way that you say this object needs some dependencies, so I will give it the dependencies, and then the object will be able to deal with these dependencies. It's like dependency injection is also like if you have, let's say, a company, and in a company you have a person, like some manager, and at some point the manager needs to delegate some works to some other people, like web developer and web designers. And then if, let's say, I would type in my manager object, I would say, okay, the developer is Hugo and the designer is Alice. If you type in with the concrete names, that means you are forced to only work with those two guys. But if you type in with some abstract type like the web developer type and the web designer type, that means you can replace Hugo by Tom and you can replace Alice by John. And it works. The manager will be able to work with two other people who have these skills of web developing and web designing stuff. Right. All right. So we'll start from a bare repository, or so in your project, just create a new empty projects. Let's write a new directory, web summer camp, let's say. I hoped the Wi-Fi network will work. We just need to use at some point Composer, so we should not rely on the internet too much for the workshop, as we will just write code. So we need a source directory where we host the code and some PHP storm or whatever favorite tools you want to use as a text editor. It's better to use PHP storm, as you know, for auto-completing the functions and class names, and especially namespaces. For this example, I have something that we can use. let's say that you are an e-commerce platform and you need to sell products on your e-commerce platform. And so you start with just regular products. So you ship one product at a time. But at some points, for special occasions, you would like to ship packages of products, like combos, all right? So you want your system to be able to create these combos, and you would like to know the price of a combo. So maybe the price can be the sum of all the products in the package, in the combo, or maybe you want a combo to be predefined with a reduced price, so that the combo will be sold with this price instead of the sum of the products in the combo. So for that, we can use a composite patterns to do this implementation. So I will open the project. Where was it? There it is. All right, so now we have just an empty source directory. So we need the first namespace, like, I don't know, web shop. And we need at least to configure some composer to create the, to tell that we have to look for classes in this source directory. Do you all have Composer on your machine? I guess you should. Is it okay for the size? From the back? Okay, cool. Yeah. All right. All right, so Composer, I think it's init. I don't remember. I think it's init. Yes. Web summer cam / design patterns. So just build a new project. Say okay, stable. It's a project license, MIT, I don't care. And not yet. Not yet. All right, so at least we have this. I mostly need to configure the auto-loading system, and then we'll be ready to go. Where's the, oh yes, do confirm generation, yes. So you should have your Composer JSON file. The most important is the autoload section. And I don't remember the syntax, as always. I think it's PSR4. I don't know if it's dash or not dash. Let's check. I usually take some examples from Symfony. I never remember the syntax of Composer JSON file. Like PSR-4, so something like that. All right. So I was close. All right, so let's say that we have web summer camp namespace under source. I guess this should do the trick. So we have this skeleton, so now we should be able to write some PHP code. We just need to generate the auto-loading files using the Composer CLI tool, and then we can start. I guess if I run Composer dump autoload, so it does pretty much nothing, as we don't have any classes yet, but we have the vendor directory. Okay. All right, so now we are all set to write our first lines of code. So we will use this example of web shops to build some patterns around it. So we will start with Composite, and we'll see how to use the Decorator. Then we'll build some builders, and then we will also use some factories or some visitors. We will see what kind of examples we can find. The goal is to have an idea of, in the end, based on these small examples, what are the benefits of using the patterns for the code base. We need to. I want to use the money class because we want to know the prices for the products. So as I introduced, it's better to use money objects. So that's a good examples for bringing this money classes. So I just hope the network will follow. I think this is this package money PHP/money. So that's the class or the package I was talking about this morning. As you can see, it provides the money class, and then you have methods to add two monies together, or to compare monies, or to allocate monies, and so on. So just bring this package, hopefully it will work. Composer require money. Okay, so while it's downloading, we can just write some stuff there. So we want to create some web shop where we have products. So product can be an interface. All right, so we have some base product interface, and then we will have two implementations. So we can have some physical product or art product, whatever you want to call it. So which defines one product that is shippable, and then we have another implementation of the interface, which is the combo product. And this one will combine at least two products inside it. So maybe you can also have some other implementation, like a digital product. Let's say that you want to sell conference tickets, so you could have some digital product class, which is a product that you can't ship using a carrier, but it's just shipped by using some emails or electronic system. But we'll just stick to those two. And so we want to have methods like get price. I want to know the price of this product. Maybe I want to know, of course, the unique identifier, the SKU, and maybe we want to know the weight. Let's say that you want to know how much weight the package weighs, so that you can calculate some fees, some shippable fees. All right. And then each classes can also have very dedicated methods that are very particular to a combo or a I don't know, for combo, maybe you want to know the number of products in the combo, like get products count. But this method is very specific to the combo class. So the interface must expose the base methods, and then the concrete classes will implement these methods. All right. All right. Did you manage to get the dependencies? It works. Maybe you can also get another dependency, which is this one. As I told you, I configure my unique identifiers with UIDs. I like using UIDs. So there's a package as well for creating UIDs, which is Ramsey/UID. And so with this package, you can generate UIDs, and you can model the UIDs as value objects. So the UIDs will be value objects, so I can use the UIDs for the SKU, for instance. So we are all set to implement our composite pattern. So we have money and we have UID package. And so we said that the web shop has two classes or an interface, and then we'll have two concrete implementations. First of all, the interface. So it's up to you to use the interface suffix. The more I work with PHP and the more I like removing the interface suffix, which forces me to use generic names, very generic names for interfaces. So like product is already very generic, so I can skip the interface suffix. And then using the concrete classes, it forces me to have real concrete names for concrete classes. I just usually have the abstract prefix if I create an abstract class, but I try to now avoid using the interface suffix as much as possible. So just my own conventions. Feel free to follow or not follow it. So the namespace is websummercamp/webshop, and it's an interface that we want to create. All right. So we said that this interface defines a product, and we want to expose, let's say, a getSku method, which must return a UID interface. Oh. Just configure my PHP storm to be on PHP 7.2, PHP. All right. So this method getSku must return a UID. We want to have a get unit price methods, which returns a money object. And at some point we will need some get weight or get mass. No, get weight. We'll have to create some weight value object. So this will be just an example for creating an example of a value object. So we will do this class later on. I would just comment this method for now. So this is what I want for my system. I want to create products with a unique identifier, a price, or maybe also a name. That would be useful to have a name, which returns a string. All right. And so now we will create the two concrete implementations. So the physical product class, which represents one single product that we want to sell on a platform, and then the combo product class, which will be the composite object. So we have products, and so now I want to have my concrete physical product class. Physical product, which is a class, and this one implements the interface. So remember, we don't want to create an invalid object, so we will simply use the construct method to initialize all the attributes that are required. So this way, we are sure to create a valid product in the system. So my product has an identity, which is the SKU, which will contain a UID, and then we have a unit price, and we have a name. And I will just set those three properties in my construct method. So we said that SKU must be a UID, and then the price must be a money object, and then we have a name. SKU. And then we have all the getters. Remember that UID and money objects are value objects, so it's safe to return them. They won't be modified as they are immutable, so it's safe to return value objects. If you return objects that are not value objects, that means, if you return objects that can be mutated at some point, that can be a risk in your code of what we called a spooky action at a distance. Like we have a getter method that returns an object which has set a method. That means at some point some other service or other class can call the getter method to retrieve the dependency and then modify the object. And that means you are changing the state of your actual object from another part of your system. And that's difficult to identify or to debug. But using value objects, you know that it's safe. You can return this value object safely. It won't be modified somewhere else because it's immutable by design. So that's another reason why I try to use value objects as often as possible in my projects. And of course, value objects provides a type, so you also have type safety when you code. All right, so we have this very simple physical product class for now, and we need the other one, which is our combo product. So let's call it combo product, and it's a class. And so this one is also implementing the product interface. We could have created an abstract product class because we will mostly have the same code in both classes, like sharing the same attributes. The thing is, at least I need the SKU, so we will have a unique SKU. Come on. UID and money. The main difference is that so we need also to have a list of product, because a combo must have at least two products, otherwise it's not a combo. So we have a list of nested products, which is required. So I will add this. I will add this new property. So we have a unique SKU, we have a price, we have a name, and I will make the price at the end because I want the price to be by default nullable, which means if I don't specify a price, that means the getter method will have to return the sum of all the prices of the products that are embedded in this combo. And if I set a price, that means I will return this price because I want to sell the combo as a more affordable price. All right, so at least we have a SKU, a name, and products. And we can have a nullable price for the combo. Products. So get SKU, get name, get unit price. So we'll have to update this part of the algorithm to iterate over the products. And I want to make sure that the list of products contains at least 2 products. So you can use the condition, you can count that you have at least 2 products. If you have less than 2 products, then you can raise an exception saying that that's not legal, it's not a valid combo. There is another library that I like to use to prevent me from creating those conditions like if not or if count products, let's say lower than 2, then throw some exception. And also, come on, like this. And then you also maybe want to check that all the products are instances of product interface. Okay, so you can have another conditions iterating over the list of products. That means the construct method becomes quite complex. So I want to introduce another useful library that I like to use, which is the assertion library from Benjamin Eberle, one of the guy who created the doctrine library. Eberle asserts, yeah, this one. So this library, asserts, allows you to create some useful assertions. Like you have this assertion class, and then you have lots of static methods allowing you to check that you have min length, max length, min, max, range, in array, and so on and so on. So they allows you to create safeguards in your methods, so you can check all the types, and then it will throw exceptions if the assertion is not met. So that's another useful library I want to introduce, Eberle/assert. So this way you can compact 3 lines of code, like a condition using an exception, into one simple assertion. And so which means less code to write and also less code to test and less risks of bugs. That's another benefits of using this type of libraries. Right, so we have Benjamin Eberle/assert. So with this library, then I can make an assertion. So as you can see, we have lots of methods in this class. So I want to check first that all is instance of. So in the products list, I want to check that we only have instances of product interface. So they can be either physical products or combos, but at least we ensure that we have only products. If I pass an array which doesn't contain products objects, then I won't be able to create a combo product instance. As you can see, this method has also extra parameters, like you can pass another message, a custom message for the exception. And you can also specify a custom property path, which will be also reused in the exception message. So first of all, we need that all object in the products array is an instance of product. And I also want to check that we have at least 2. So minimum. So value, min value, yeah. Can be mixed. At least, no, it's min. Okay. All right, so we are sure that the combo object is correct when it's created. So we have a consistent object. And the last part is to now implement the getUnitPrice method. So if we have a unit price set, then we can return it. That's the custom unit price. Otherwise, we have to compute the price by iterating over the list of items, of products in this package. Let's say like this. From 1 to these products. So I want to iterate from 1 to max. No, the other way around. And so remember that total price, or the get unit price method returns it returns a money object, and so we can safely say that products I get unit price, and I want to add it to my total price, like add like this, and return the total price. By the way, that could be interesting to encapsulate the products list into a dedicated collection class, so that we can expose methods like get total price or get price. That could be one of the benefits. Remember, the object calisthenics treat collections or treats lists or arrays as collection. In this case, that could be interesting to have a price list or products list collection. Yeah. And just to prevent some failing tests, as you can see, the keys must be indexed from 0 to n. So just as a safeguard, you can also force to get only the values in your construct method. So this way you are sure to always have keys starting from 0. Just in case this product has associative keys. In this case now we will only have index keys. All right, so now we have this composite. I don't want to expose an add method, but maybe if you want to have an add method, you can also expose this add method to add a new object to the combo. It's really up to you. I will consider that the combo must be pre-configured first, and then all the products for this combo must be given to the combo. All right, now we need to test that. We can use PHP unit to run to test this this example. That's a good fit for doing some unit test and to prove that everything works. All right, so we need to bring PHP units. So we can require PHP unit as a development dependency. So this is why we have -- dev. I think there is a TDD workshop tomorrow as well. So. It's one of the first conferences where the Wi-Fi looks good. I usually have troubles installing all of these composer dependencies. That's good. Right. All right, so now we have PHP units. Do we have a bin directory? No, it's in vendor. Yeah, so we have vendor, bin, and then PHP units. All right, so PHP unit is there, and now we need some test directory. And then we have webshop subdirectory. And I want to test my two classes. Maybe we can just test the product by testing the product. We will also test the physical product as well. So let's write a test for the combo product. So combo product test class, which is inside, let's say, web summer camp /tests /webshop. Again, we'll need to configure this namespace. We'll need to configure this namespace into Composer. So I want to extend the base test case class from PHP unit. So I will do the test for the physical product here, but it should be better to have a dedicated test case class. I will do all the tests for the webshop here. So first of all, we can test that single product, like test single physical product. That's the first test we need. And then we need two other tests, like testing a combo which has a custom price and testing a combo which doesn't have a custom price. And we can also have a test to ensure that the combo must have at least two products, and the test should fail if we, well, I mean, it should pass if the exception is raised by the assertion library. All right, so we have this one, so I want to create a new physical product. And so we said that we need a UID. So for the UID, it's up to you to generate a new UID or to create one. As you can see, the UID class. In the UID class, you have several methods, like UID4 if you want to generate a new one. But you can also use the fromString method if you want to pass a custom UID. So what I do is to, for instance, going to some UID generator service online, like you have this website, UID generator, and then you just copy paste one generated UID. So it's a UID 4, and that will be my UID for the test. So I know that this is a fixed UID I chose. And then we need some money. So I want a money object. So the amount will be, let's say, 120 euros. So it means 120, yeah. So 12,000 cents. So you always express the amount in the smallest units. So in cents for euros. And I have to pass a currency. The money package also has a shortcut syntax where you can also write money using a static method, which is a virtual method. You can write it down like this. It also works. So there is a call static method that is implemented that will create the currency object based on the this syntax or this virtual method. It's up to you. I will take the expanded syntax, and then we have the name. Or let's say, yeah. So web server camp. All right, so we have this, and now we can perform the assertions. Like I want to ensure that we have assert equals. So I will not use assert same, but assert equals. Because assert same, if you use assert same method, assert same is a triple equal sign comparison. It's a strict comparison. So that means if you compare objects, assert same requires that the two instances are in fact the same object in memory. But with assert equals, it's not a strict comparison, which means you can compare that two objects are equals. They are siblings, basically. So in our case, I want to compare like that we have this, we have the same UID object when I called product gets coup. All right, so this method will return this instance in memory, and I want to compare it with this object. Remember that value objects are equal if they contain the same state. So those two objects are not the same instance in memory, but they are two siblings object, or two equal objects. All right, now we have same for the money. So this assert equals, so I want to expect to have this price if I want to get the unit price, and the last one is the name. So I would just make assert same, because in this case it's a string, so I expect to have web summer camp as the product name. All right. So if we didn't make anything wrong, the test should pass. We have to configure PHP units. Just checking that. Yeah, autoload dev. In your composer JSON file, you need to add this new section, autoload dev, and we will say that for the web summer camp /test // namespace, then we are going to find the files under the test directory. Okay, so don't forget to bring this new couple of lines into your composer JSON file and run the dump autoload command once again, just to regenerate the autoloaders. And so now we'll be able to run the test. Hopefully the test should pass with PHP unit. And then we will test this the composite object, which is the subject of this example. So composer dump autoload. I will also create a GitHub repository where I will push the code, so that if at some point you missed something, you can also get the final code. And I will also at the end push the slides, the presentation slides, into the repository. All right, so hopefully if I run my vendor bin PHP unit command, does it work? I have to pass the test directory. Yeah. So from the root of the project, and we call vendor bin PHP unit executable file, and we pass it the test directory. You can also configure a php.xml file if you want to have to avoid passing this test directory explicitly. So we tell PHP to run all the tests found under the test directory, and as you can see, we have one test that was executed with 3 assertions, so it works. The physical product class is correctly implemented. And so now we can test the composite object. So first of all, I want to test an invalid combo product, combo products. I will try to pass an empty array or just one product into the list of products, and I expect to get the exception. I want to make sure that we can't create a product which doesn't contain at least 2 products. So if I try to create a combo product, so again, so for the screw, I don't care about the screw. I can generate the screw because for the test we don't care. We just need a UID and then the name. And then we need a list of products, and I would just have 1 product. Same here, I can just generate a random UID. So trying to create a combo with just 1 product should fail, so we should expect to get an exception. I don't know exactly the type of the assertion from the Benjamin Herbelay assert from the assert library, so I can check what kind of exception does it raise. It's an assertion failed exception, so we must accept this type of exception. So let's add expected exception, and it must be this type of exception. So as you can see, if you are not familiar with PHP unit, you can have annotations, and you can configure the expected type of exception that you are supposed to raise in this particular use case. So this way, I'm going to be sure that a combo that doesn't contain at least 2 products is not supposed to be valid, and it works. So that's good. We didn't make any mistakes so far. So now we want to check the price. So the price must be, we need a test to check that the price must be either the one that we configured, and another test where it should be the sum of all the products we have in the composite. So let's try test, let's say combo products with custom price. So we have combo. So I'm just interested into the price. So I want to embed 2 products. Let's say. Right, so I'm just having 2 products with different prices. So let's say this one costs, let's say, 90 euros, and this one is 120. Product. Another reason why we could have a class for representing the collection would also be to ensure that we have the same currency in all the products, that we can't add USDs with euros, for instance. So when you create your list of products, you could also check that all the products in the list have the same currency. Otherwise, you could raise an exception. So I want to create this combo product with a dedicated price. So we have the list of products, and then we have a custom price. So let's say that we want to sell this one for 145 euros. So we expect the price of this combo to be 145 euros instead of 210 euros. Just make it more visible. Right. So we want to assert. So this is the methods, that is the composite method. So we want to check that the price must equal 145 if we request for the combo, if we request the unit price of the combo. And so we have something fails. The value array is not numeric. Oops. Where's the problem? I think that's the mean value. Combo product 23. Yeah, that's the mean. What could be the assertions for this one? It's not mean. Do we have the list? Try. As you can see, there is a nice syntax also to make more complex checks. It's min length? Okay. I thought it was just for strings, but yeah, it maybe works for arrays. Nope, expect it to be string. So it's not min length. Choice. Do this count? Or maybe greater than. Max length. So now the test passes, but it doesn't pass for the greater than or equal than. Nope. Let's try something else. Mean and then count. Yeah. So I can still use mean and then count, and then we compare that. This value is greater than, or it's at least 2. All right, so as you can see, the 3 tests pass. So we managed to check that if we have a custom price, this is the return price. And we need another test, the last one, to check that if we don't have a custom price, we will get the sum of all the product prices. And we can also make it more complex with nested combos. We can have nested combos, so let's try test combo, let's say test complex combo product without custom price. So we have a physical product, and we have also a nested combo product with its SKU and name. Let's say nested combo. And this one has also a list of products. All right, it's a bit difficult to read. So there's one physical product, so this one, which is 120 euros. And then we have a nested combo, which also has 2 physical products with different prices. And I don't have any custom price, so I didn't define any custom price, so I expect the total price to be 120 plus 90 plus 80. So that's the magic of Composite. You can embed any sub-levels of physical products or combo products into your combos. So I have a super combo. And so my super combo doesn't have a custom price. So it embeds, in fact, 3 products, this one, and this one. And so I expect the total price to be 290 euros. So 290 or 29,000 cents. Yes, it works. So as you can see, using the composite is super simple. It doesn't require too much code, but you can make this. You can fulfill this useful requirement of traversing a complex object using one single operations, which simply does some sort of recursive operations on the children objects. So now we have fully tested what we wrote as code, so the single products, and the combo products and super combo products with custom price or without custom prices. I can just make a git init. So I will push that to a repository later. All right, makes sense for this first example? Any questions? No, it's okay. Okay, we have 10 minutes. So I can move on onto the decorator just for the explanations, and then we will try this one after the break, after the lunch. All right, so we saw the composite. Now you will see the decorator, which is quite similar to composite, but they don't serve the exact same purpose. All right. So basically, the decorator patterns allows you to add new responsibilities to an object, but without changing its class, just by creating new classes. It's a way to extend an object. Remember the open-close principle. You should be able to open an object behavior or a class behavior without changing the class of this object. So decorator is probably the design pattern which really leverages this open-close principle. This is the UML diagram. As you can see, it's quite similar to the composite because in the end, the decorator is a composite pattern. We will leverage object composition. So we still have a base class or a base interface which provides some set of public methods. And then we have a concrete component. This is the object that you want to decorate. So this is my initial implementation of my component. And at some point, this class, I want to decorate this object. I want to add extra responsibilities to this object. And this is why I will implement decorators. So the decorators are usually defined as an abstract class. I mean the decorator abstract class. And then all the concrete decorators will extend the base abstract decorator. As you can see, inside the decorator, we embed the components, any components that we want to decorate. So it can be any concrete component or any decorator component, so that you can have several layers of decorations. Like for an onion, you have lots of layers in the onions. Why do we use this pattern? The most useful case is for extending the object without changing the class. So you don't want to rely on the inheritance. So you don't want to inherit the class that you want to extend. You will decorate it. You will compose objects. That's mostly the problem. You don't want to use vertical inheritance because at some point you will see that inheritance, as you can only inherit one class at a time, at some point it makes combination impossible. If you want to have a different set of combinations when decorating your objects, You can't do it with inheritance. I have a use case. Just I want to explain one use case. I don't have in the slides, but let's say you have a simple pen. Imagine you have a pen object. This is your main class. This is the object that you want to decorate. So you have a pen class. And so the pen is very simple. It just writes in black, or it just writes something. So this class, let's say, has a write method where you give it a text, and it returns the text that you want to print out. And now the business changes. You have new requirements. As a company, you want to sell a more complex pen. You want the pen to write with a particular color, or you want a pen which writes in Riverside, or you want to have a pen that allows you to write in uppercase, for instance. So this is something that you can't achieve with inheritance, because if you start making subclasses like a bold pen to write in bold, so you have a bold pen class that inherits pen, and I also want to have an italic pen class if you want to write in italic. The thing is, if you want to write both in bold and italic, then that means you need to create some weird class which is bold, italic, pen class. Because you can't make a class that both extends bold and italic. So this is why we don't want to use inheritance, because with single inheritance, we can't make a complex combination. If I want to create a pen which writes in bold, in red color, in italic, and in uppercase, that means I need to create this weird class, bold, italic, red color, uppercase pen class. So as you can see, it's better to have a decorator, because with the decorator, I have my concrete pen object, which can be implementing some writer interface. And then, so we have a writer interface, which just provides a write method. So that's the concrete class. And then I will have some writer decorator. This is the decorator class. And now I can create as many combination. So I can have a bold writer, which is a decorator. I can have an italic writer, and so on and so on. So I can create now lots of combinations. And so in the end, I will have something like new, let's say, italic writer, which decorates a bold writer, which decorates the pen object. All right? And you can make as many combinations. If you want to have a pen which writes in red color, or which writes in uppercase, or which, let's say, remove any words that is injurious, then you just need to create a new class which does the job. And then you make the combination. And the good thing is that you can also decide in which order you apply the decorators. In this case, we will first write. The text we write will be decorated in bold, and the bold will be decorated in italic. But if you want to first write in italic and then decorate it with bold, then you just reverse the decoration order. So that's the main reason why you would use decorators. You want to create infinite combinations of decorations without any limitations. In Symfony, we use this pattern in several locations. And one of the most interesting part is the HTTP kernel component. This is the main object which converts an HTTP request into a response. So HTTP kernel is a base object that implements HTTP kernel interface. And on top of the HTTP kernel, we want to provide some HTTP caching support. So in the Symfony frameworks, we have a new class called HTTP cache, which is also an implementation of the HTTP kernel interface. And this is how it looks like. We have the base interface, HTTP kernel, which has this handle method. Handle takes a request, returns a response. The main implementation, the standard implementation is HTTP kernel. But if we want to add some caching capability to this HTTP kernel, then we have this HTTP cache decorator object. And HTTP cache wraps any object that implements the HTTP kernel interface. So this is how in Symfony then we use this HTTP cache. So as you can see, we have the main kernel. This is the base one. But we want to decorate this kernel with HTTP cache so that any responses that we generate can be cached or not cached in a storage system like Redis or file system. In this case, the store is a file system store, as you can see. We are caching to some directory called http_cache. So whenever you handle the method or you handle the request, in this case, we are handling the request through the cache so that the cache can check, do we have a response that is already cached for this request? If yes, return it. Otherwise, delegate to the inner HTTP kernel object that produces the response. And then when the response has been generated by the inner HTTP kernel, we will decide whether or not this response must be cached before being returned by the handle method. So as you can see, this is how it works. We decorate any HTTP kernel, so they both implement HTTP kernel interface. So we have a new kernel which wraps or decorates an existing kernel. And at some point in the endo method at some point calls this forward method. And as you can see, we do some logic. So this is where we dynamically add responsibilities to the kernel object. So the HTTP cache object adds this part of the logic before handling the request. And then it delegates the rest of the logic to the inner kernel because this HTTP cache object doesn't have enough knowledge to process the request. It just does caching. So processing the request is delegated to the decorated kernel. And then we get the response. And here at some point, it's going to decide whether or not the response has to be cached in the system. All right? All right, so we can go to get some food, some lunch. We are back in 1 hour. And so we will implement this example we will implement the decorator with some web shop system. As you will see, we will try a coupon system. We want to be able to create coupons for reducing an order amount. That will be the use case. All right. Any questions so far? That's clear? Good. I don't know if the room is closed, so I would recommend to get your laptop with you, just in case.